Good day, class. We had our first lesson on the first derivative where we looked at how to form the derivative of any polynomial function. We used this one rule: the derivative of x to the n is equal to n times x to the n minus 1. We applied this rule to each term in the polynomial and simply added and subtracted those results to get the full polynomial derivative. Well, today's class is going to focus on functions that are raised to an exponent. So now perhaps you have your polynomial and it has an external exponent. This rule that we're using is often referred to as the chain rule. Okay, so here's the rule itself. The derivative with respect to x of u to the n. So here u is a function of x. So u could be a binomial or a trinomial. Okay, so what you do first is n times u to the n minus 1. And then you multiply that result by the derivative of the function u itself. Okay, so I'm going to show you that very same thing with our specific examples. So here's example 1. So you can see we have a binomial and it's raised to an external exponent. So u here, u is the inside of the bracket. Okay? U is 2 minus 3x squared. We're going to need to be multiplying by its derivative. So maybe we should start by working out what its derivative is. Now, we learned this in the last video. So first you start with the derivative of 2. Now remember, 2 is a constant. So its derivative is 0. And then we have minus 3 times the derivative of x squared, which is 2x to the 1. So overall, we have that the derivative of 2 minus 3x squared is simply negative 6x. Okay, so what is the derivative of this function y? The derivative of y with respect to x is equal to, first we do this part. So the exponent comes forward. Then we subtract 1 from the exponent to make it 2. Then we multiply by the derivative of the inside of the bracket, or the derivative of function u. And its derivative is negative 6x, like this. In writing our final result, we can multiply negative 6x by 3 to get negative 18x in front of the square of 2 minus 3x squared. And that's how you form the derivative of what I will call a power function. It's a function raised to an exponent. Okay, and again, it's sometimes called the chain rule as well. All right, let's try a second example. It doesn't at the moment appear to be a function raised to any power. But we have to remember that if we were going to differentiate this, we can't have it in this form. In fact, we would bring the binomial up so that we would have 3x plus 1 to the exponent of negative 1. So this is just rewriting the original function y. And now, in fact, we do have sort of a u to the power of n. Okay, so we do, in fact, have now a power function. So we've got a binomial with an external exponent. Okay, so we can actually identify what u is. U is the inside of the bracket, 3x plus 1. Just like over here, u is the inside of the bracket. Okay, we need its derivative. The derivative of 3x is 3. If it's helpful to you still, if you still need to do that, remember it goes like this. 1 times 3 is 3, and then you subtract 1 from the exponent, right? So you get 3x to the 0. And then you would do plus the derivative of the constant 1. The derivative of the constant is equal to 0. If it helps you, you can change this into 1 times x to the 0 to explain why the derivative is 0. As soon as the 0 comes forward to multiply by the 1, you get a 0. Okay, so the derivative of 3x plus 1 is 3. 3 times 1 plus 0. Okay, so the derivative of the inside of the bracket is 3. So the derivative of the function y with respect to x would look like this. The negative 1 comes forward and multiplies by the negative 2. So now we will have positive 2. We repeat the inside of the bracket. We subtract 1 from the exponent and it will be negative 2. And then we multiply by the derivative of the inside of the bracket, which we already determined was 3. Okay, so again, the exponent comes forward, 1 is subtracted, and then multiply by the derivative of the inside of the bracket. The exponent comes forward, multiplies by the negative 2 already there, 1 is subtracted from the exponent, and then multiply by the derivative of the inside of the bracket. So what does this give us? 2 times 3, 6 will be in front of 3x plus 1 to the negative 2, and then we're going to rewrite this with a positive exponent, and that of course means dropping 3x plus 1 to the denominator so that the exponent will be positive 2. Okay, so the derivative of this original function is this. Okay, we'll do a couple more together. Okay, so here we go. Here is our third example. We have the cube root of the binomial 5 minus x cubed. So we begin by eliminating the radical. Remember that the fractional exponent here will be 1/3. The implied exponent on the binomial here is a 1. So we get 1/3 for the fractional exponent. So now we certainly have u to the n. U to the n. We have a power function. We will use the chain rule. Okay, what is u? U is 5 minus x cubed. What is the derivative of u? The derivative of the constant 5 is 0. So we have 0 minus, what is the derivative of x cubed? It is 3x squared. So the derivative of u is just negative 3x squared. Okay, so here's y. Its derivative with respect to x. Make sure you change the notation. Don't leave this as a y. This is now dy by dx. So we start. We bring 1/3 forward. Then we subtract 1 from 1/3. This will be negative 2/3. By the way, you can use your fraction button to help you with all of these things. So 1 minus, now to put in 1/3, you use the exponent, the fraction button here. 1/3. So can you see that? 1 minus 1/3 equals, and you can see that the calculator has given you negative 2/3 as your result. Oh, I'm supposed to do 1/3 minus 1. Sorry about that. Should we try that again? I was supposed to do, of course, 1/3 subtract 1. 1/3. There you go. Subtract 1 equals, there it is, -2/3. You can see I'm much better not using the calculator. Okay, anyway, yes. So the exponent came forward. Then we subtracted 1 from 1/3 to get -2/3. Then we multiply that by the derivative of the inside of the bracket, which we've already worked out over here. And it's -3x². Okay, simplify. Take 1/3 and multiply it by -3x² to get -x². -1x². Okay, like this. Next, make the exponent positive. So into the denominator will go 5 minus x cubed to the +2/3. And now finally back to radical form. So I like the final results to look like the original questions. So if we started with radical form, we will be ending with radical form. Okay, the 3 is the index here, while the 2 is the exponent here. Okay, perhaps we'll do one more example together before you immediately try a few on your own, okay? So here we go, example 4. No good to have that radical sign there. So, first thing, remove it. So it's the square root, which is equivalent to a 1/2 fractional exponent. This is still not appropriate for differentiation because the variable is in the denominator. So we go one step further and we make the exponent -1/2. Okay, now look. Do we have a u to the n form? Yes, we do. U is the binomial inside here. N is the number -1/2. Okay, so u is x² minus x. What is its derivative? The derivative of x² is 2x. All right, it would be 2x to the 1 minus, what is the derivative of x? The derivative of x is 1. If you still need to do this, you go 1x to the 0, okay? So we end up with 2x minus 1. 2x minus 1 is the derivative of x² minus x. It's the derivative of the inside of the bracket. Okay, so now let's do the derivative of y. So here we have u to the n. So how do we form the derivative of y? First, n times u to the n minus 1. So what does that mean? It means first, the exponent comes forward, and then 1 is subtracted from the exponent. -1/2 minus 1 is -3/2. Because it's the same, of course, as -1/2 minus 2/2, right? But if you want to do it with your calculator, -1/2 subtract 1 equals, now look, it's giving you the mixed fraction, -1 and 1/2. But if you push shift and hit that fraction button again, you will get -3/2, which is the correct improper fraction. So we've done the beginning of the problem here, -1/2 u to the -3/2, and then multiply that by the derivative of u, which is 2x minus 1, like that. Okay? So how do we clean this up? Well, we're not going to multiply -1/2 through by the binomial because, well, we have a 1 here, so we'd end up with a fraction. So all we're going to do is rewrite this like this, first of all. So -1 and 2x minus 1 can be in the numerator. In the denominator already is 2. This 2 is in the denominator. And this can drop down such that its exponent would be +3/2. Okay, so we left the -1 and the binomial in the numerator. The 2 was already in the denominator. We brought this down such that it would have a positive exponent. And lastly, we're going to go to radical form in that denominator. So after the 2, we're going to have our radical. The index is 2, so we don't write it in because it's implied. And the exponent here would be a 3. Okay? All right, so each of these questions, if you don't want to show this off to the side, it's okay. This business here, each of these questions requires you to do this full formula. So first, the exponent business, keeping u the same, then the derivative of u. Right? So here's the other one. First, the exponent business, then multiply by the derivative of the inside of the bracket. Again, here it is. First, the exponent business, keep u the same, then multiply by the derivative of the inside of the bracket. And once more, here's the original y function. First, the exponent business, keeping u the same, then multiplication by the derivative of the inside of the bracket. Following that is the simplification each time. Okay, so there are questions from your textbook. Not too many of them. You're going to do 13 through 23 odd. I will be posting the details of that for you in Blackboard. Remember that I have included in the course documents folder solutions provided by the Pearson publisher to accompany the textbook. So when you're doing your homework, if you're stuck on a homework problem, first consult that packaged solutions manual. And that should help you to complete the homework. And of course, any remaining questions at all can be directed to me through email. Okay, thanks a lot. Have a great day.